What's up everyone, it's Stack Lessons here. Welcome back to the channel. Today we're diving into Checkpoint 1, Core Services Retrieval Challenge. Let's get into it. By the end of this video, you'll know exactly which core services you've actually internalized, and which ones still need work. Because we're going to test you the same way the Amazon Web Services Certified Data Engineer Associate exam does. No new content today, just 12 scenario questions deliberately mixed across Glue, Kinesis, Athena, Redshift, S3, and Lake Formation. If you can answer these under pressure, you're ready. If you can't, you'll know exactly where to go back. Here's the uncomfortable truth about watching tutorial videos. It feels productive. You nod along, you understand every word, and you walk away convinced you've learned it. Then the exam puts a scenario in front of you and your brain freezes. Watching is not the same as recalling, so today we're skipping straight to recall. On the left, passive rewatching. It feels productive, it creates this comforting illusion of fluency, and it fades within days. It's like watching workout videos and expecting to get stronger. On the right, retrieval practice. It feels harder, sometimes uncomfortably so, but it forces your brain to actually pull the information out, and research shows it produces roughly 50% better long-term retention. That's the difference between watching someone lift the weight and lifting it yourself. And we're not just doing retrieval, we're interleaving. Instead of grouping all the Glue questions together, then all the Kinesis questions, we're going to jump between services in random order. It feels harder, and that's exactly the point. The exam doesn't hand you a question with a label saying this one's about Kinesis. It forces you to discriminate, so we'll practice discriminating. Each question follows 4 beats. The question, a 3-second pause, the correct answer, and the wrong options breakdown. Here's how it plays out. First, the question appears on screen with all 4 options, and I read it aloud. Then comes the 3-second pause, commit to an answer, out loud or in your head before I move on. Next, the correct answer is revealed with the full reasoning. Finally, we walk through why each trap is a trap. On the exam, knowing why wrong answers are wrong is half the battle. 12 scenarios, 6 services, random order. First up, Amazon Web Services Glue handles ETL and the data catalog. It's the backbone of every batch pipeline you'll see. Next, Kinesis captures streaming events in real time, giving us sub-second ingestion when the question mentions clickstream or telemetry. Then Athena enables serverless SQL directly over S3, the go-to engine for ad hoc analytics. From there, Redshift powers warehouse-scale workloads, where sort keys and distribution styles will trip you up if you're not careful. Sitting underneath all of it, Amazon S3 is the central storage layer for the entire lake. And finally, Lake Formation governs access across every table and column. No grouping, no gentle warm-up, no telling you in advance which service the question is about. Just like the real exam. All right, pencils up. Question 1. A nightly Glue job reads from an S3 path partitioned by year, month, and day. The team wants it to process only the new day's files without rereading 3 years of history. What feature solves this with minimal code change? Is it A, run a Glue crawler before each job to register only new partitions? B, enable Glue job bookmarks on the ETL job? C, switch from DynamicFrame to DataFrame and filter by date? Or D, add a pushdown predicate that hardcodes yesterday's partition? 3 seconds, commit to an answer. The answer is B, Glue job bookmarks. This is the textbook trigger phrase, process only new data without reprocessing, and bookmarks are exactly what Oz built for it. They track state at the file level between runs. Why not the others? Crawlers register schema, not process state. They don't know what your ETL job already consumed. Switching from DynamicFrame to DataFrame changes nothing about incremental processing. And a hard-coded predicate is brittle. It breaks the moment you need to backfill or rerun. Question 2. 3 downstream applications must each consume the same clickstream independently, and one team needs to replay the last 24 hours after a bug. Which service fits? A. Kinesis data Firehose delivering to S3 with each app reading from S3. B. Amazon SQ as standard queue with 3 subscribers. C. Kinesis data streams with the required retention period. Or D. Amazon MSK serverless with a single consumer group, 3 seconds. The answer is C. Kinesis data streams. Think of data streams as a reservoir, durable storage, multiple consumers, 1 to 365 days of retention with full replay. Why not the others? Firehose is the Firehose itself. It blasts data to one destination and it's gone, no storage, no replay. SQS deletes messages after consumption, so multiple independent consumers don't work. An MSK with a single consumer group means each record gets read once, not by 3 independent apps. Question 3. An Athena table has 500,000 daily partitions in the Glue catalog. Queries are slow because partition lookup dominates runtime. What's the lowest effort fix? A. Run MSK repair table before every query. B. Enable partition projection with the date and now configuration. C. Recreate the table with CTAS using fewer partition columns. Or D. Switch to Athena Spark notebooks instead of SQL 3 seconds. The answer is B. Partition projection. It computes partition values in memory from table properties, completely bypassing the Glue catalog lookup. No crawler, no MSK repair, no remote metadata round trip. Why not the others? MSK repair actually makes the problem worse. It adds another slow catalog operation. CTAS, or create table as select, is for format conversion, not partition resolution. And Spark notebooks are a different query engine entirely. They don't fix the underlying partition lookup issue. Question 4. A 200-row date dimension is joined to every fact table in a star schema. Which distribution style minimizes redistribution at query time? A. Distribution style even, round robin across slices. B. Distribution style key on date_IDC, distribution style all, replicate the table to every node. Or D. Distribution style auto, let Redshift decide, 3 seconds. The answer is C. Distribution style all. 200 rows is tiny and it's joined to every fact table. Replicating it to every compute node eliminates join redistribution completely. Why not the others? Distribution style even forces a shuffle on every single join, terrible for this pattern. Distribution style key on date_ID only collocates one join and you have many. Auto might eventually land on all, but the question asks for the deliberate optimal choice. All is only unsafe on large or frequently updated tables. 200 rows is neither. Question 5. Auditors call. They need an archived object back within 10 minutes. The object lives in cold storage. Which configuration satisfies the requirement? A. S3 Glacier Deep Archive with standard retrieval. B. S3 Glacier Deep Archive with expedited retrieval. C. S3 Glacier Flexible Retrieval with expedited retrieval. Or D. S3 Glacier Flexible Retrieval with bulk retrieval. 3 seconds. The answer is C. Flexible Retrieval with expedited. Expedited gives you 1 to 5 minutes, comfortably inside the 10-minute window. Why not the others? Here's the trap: Deep Archive has no expedited option at all. Only standard around 12 hours and bulk up to 48 hours. So options A and B are wrong, and B is actually impossible to configure. Flexible bulk is 5 to 12 hours, far too slow. Remember this one: Deep Archive plus expedited is a classic distractor. Question 6. A governance team must grant analysts access to any table classified as non-PII across hundreds of existing and future tables, with 0 manual updates as new tables land. Which approach? A. Grant select on each table via named resource permissions, then automate via Lambda. B. Use lake formation LF tags, tag tables with classification equals non-PII, and grant on the tag expression. C. Write an IAM bucket policy referencing every table's S3 prefix. Or D. Use glue DataBrew recipes to mask sensitive columns at query time. 3 seconds. The answer is B. LF tags. Think of them as wristbands at a festival. Tag a new table with classification equals non-PII and access is granted automatically. 0 manual updates. Why not the others? Named resource grants don't scale and break on every new table. Automating with Lambda is patching a fundamentally wrong approach. IAM bucket policies bypass lake formation entirely, losing column and row level control. And DataBrew is for data preparation, not governance. It's the chef, not the maitre d'. Quick pause for a reinforcement quote straight from the Athena docs. Partition values are calculated from table properties rather than read from a metadata repository, and in-memory calculations are faster than remote lookup. That's the entire reason partition projection exists. If you see slow queries plus huge partition counts on the exam, this is your answer. Question 7. A nightly glue job is non-urgent and can tolerate variable startup time and occasional retries. The team wants to cut DPU cost by roughly a third. What's the right configuration? A. Switch the job to the Flex Execution class. B. Switch the job to Glue DataBrew. C. Reduce the worker type from G.2x to G.1x and hope for the best. Or D. Move the workload to EMR serverless for cheaper Spark. 3 seconds. The answer is A. The Flex Execution class. Flex trades guaranteed start time for roughly 35% lower DPU cost. A perfect match for non-urgent, cheaper, variable runtime is fine. Why not the others? DataBrew is no-code visual prep, not an execution mode for ETL jobs. Downsizing workers risks out-of-memory failures and doesn't directly control the cost knob. And switching to EMR serverless is a full refactor, not a configuration change. Flex is a one-property toggle. Question 8. A Lambda consumer on a Kinesis data stream shows getRecords.IteratorAge milliseconds rising steadily. CPU and memory on Lambda are low. What's the most likely fix? A. Reduce the stream's retention period to force faster processing. B. Switch from data streams to Firehose to remove the bottleneck. C. Lower Lambda's batch size to 1 record. Or D. Increase Lambda's parallelization factor or add shards, optionally enabling enhanced fanout. 3 seconds. The answer is D. Add parallelism. IteratorAge is how far behind your consumer is from the stream head, like the oldest customer waiting in a checkout line. Low CPU means Lambda isn't the bottleneck, there just aren't enough consumers. Add more shards, raise the parallelization factor, or enable enhanced fanout. Why not the others? Reducing retention doesn't speed processing, it just loses data faster. Firehose has no replay and isn't a drop-in replacement. And batch size of 1 makes per invocation overhead worse, not better. Question 9. Finance wants the BI team capped at 100 gigabytes scanned per query in Athena with separate query history and a dedicated results bucket. Which feature delivers all 3? An Athena workgroup with bytes scanned cutoff per query and its own results location. B. An IAM policy with a condition on S3: get object byte size. C. Athena federated query restricted to S3 only. Or D. CTAS to pre-aggregate the data so scans stay small. 3 seconds. The answer is A. An Athena workgroup. Workgroups are purpose-built for per-team isolation. They give you scan caps via byte scan cutoff per query, dedicated history, and a dedicated results location, all 3 requirements in one feature. Why not the others? IAM cannot enforce byte scan limits. There's no such condition key. Federated query is about reaching new sources like RDS or DynamoDB, not about enforcing cost. And CTAS optimizes data shape, but doesn't enforce per query limits on the BI team's behavior. Question 10. A developer wants to insert new rows into a Redshift Spectrum external table backed by S3 Parquet. Which statement is correct? A. Use copy with the external keyword to insert into Spectrum tables. B. Spectrum external tables are read-only. Use insert into with Parquet format only. C. Spectrum external tables are read-only. Write to S3 directly using unload, or use a regular Redshift table. Or D. Enable concurrency scaling on the Spectrum query to permit writes. 3 seconds. The answer is C. Spectrum external tables are strictly read-only. You can select from them all day, but you cannot copy, cannot insert, cannot update. To write, you either unload from a regular Redshift table to S3, or your pipeline writes to S3 directly. Why not the others? There is no external keyword on copy for this. Option B contradicts itself. Read-only means no insert, period. And concurrency scaling adds red burst capacity. It has nothing to do with write permissions. And here it is in black and white from the Redshift docs. Spectrum external tables are read-only. You can't copy or insert to an external table. This is the single most missed Spectrum fact on the exam, so commit it to memory right now. Question 11. A new analytics dataset has unknown fluctuating access. Some objects will be hot for weeks then go cold, others will be ignored from day one. Cost must auto-optimize with no admin tuning. Which class fits? A. S3 standard with a lifecycle rule to IA at 30 days, Glacier at 90. B. S3 intelligent tiering. C. S3 one zone IA as the default for cost savings. Or D. S3 Glacier flexible retrieval with frequent restores. 3 seconds. The answer is B. Intelligent tiering. The trigger phrase is unknown or changing access patterns. Intelligent tiering is the smart fridge. It watches what you actually access and moves objects automatically with no retrieval fees. Why not the others? Lifecycle rules require predictable patterns, which is exactly what we don't have. One zone IA drops an availability zone for a cost cut, but it's not about access patterns and it breaks high availability. And Glacier flexible with frequent restores would crush you on retrieval time and fees for the hot objects. Final question, number 12. A business analyst with no coding skills needs to clean, normalize, and join CSV files visually before loading them into the data lake. Which service? A. AWS Lake Formation. It governs the lake and can prepare data. B. AWS Glue DataBrew. Visual no-code data preparation with 250 plus transforms. C. AWS Glue Studio ETL job authored in Spark. Or D. Amazon EMR Studio with a PySpark notebook. 3 seconds. The answer is B. Glue DataBrew. The trigger phrase is analyst with no coding skills plus visual data preparation. DataBrew is the textbook fit. Why not the others? Lake formation governs the lake, its access control and permissions, not data prep. Glue Studio still requires Spark or SQL knowledge, even with a visual editor. And EMR Studio absolutely requires coding. Remember the analogy from the lake formation episode? DataBrew is the chef in the kitchen. Lake formation is the maitre d' at the door. Different jobs entirely. Here's the full NexaRetail platform after core services. Kinesis data streams feeds Firehose, which lands in the S3 lake, gets cataloged in Glue Catalog, queried by Athena and Redshift serverless, and governed by lake formation. Now let's walk it. Kinesis data streams captures clickstream events from the website in real time. Firehose delivers those records into S3 in Parquet format. The S3 lake is the center of gravity, with lifecycle rules moving cold data to Glacier. Glue Catalog tracks every table, populated by crawlers running on a schedule. On the query side, Athena serves analysts with workgroups and partition projection. Redshift serverless powers the executive dashboards, with Spectrum reaching back for cold history. And Lake Formation ties governance across all of it, with LF tags controlling who sees what. Ingest, store, catalog, query, govern. Every box is a service you must recognize on site. Honest self-assessment time. 3 tiers here. 10 to 12 correct means you're exam ready on core services. 7 to 9 correct means targeted review of the topics you missed. Below 7 means rewatching the weak core service episodes before you push forward. Now let's unpack each tier. The 10 to 12 range, keep that momentum going, but don't get cocky, because storage and operations questions are coming next. The 7 to 9 range, go back to the episodes covering the specific questions you missed and watch them with the scenarios fresh in your mind. And the bottom tier, there's no shame in this. The whole point of a checkpoint is to find the gaps before the exam does. 5 things to lock in before you close this video. Retrieval beats rewatching every single time. Interleaving forces the real discrimination skill the exam tests between similar services. Missed questions are gold. Read the wrong option explanations twice, because that's where the exam traps live. Schedule a second pass through this checkpoint in about 3 days. That's the spacing effect doing its job for free. Next stop. Storage and operations, which is exactly where this series goes from here. See you in the next episode. And that's a wrap on Checkpoint 1, Core Services Retrieval Challenge. If this helped you out, smash that like button and subscribe for more. See you in the next one.